So here's a peculiar looking circuit. This is a shift register, and it's not designed exactly the way you would normally design a shift register with digital components, but it was done this way for reasons of the circuit that it was intended to go into. But here's a simulation of it. Basically, I have a 5-stage shift register, and my stages are aligned vertically, so each of these columns of 4 cells will hold 1 bit, and my clock will come in here on the north of this 6th cell. So I can tick the clock and nothing is happening. My input to the shift register is here, my outputs are on the bottom, and my final output is on the right. So the way this works, it's negative edge triggered. So if I load a 1 into the D input, nothing happens until the clock drops. When the clock drops, that first 1 gets shifted into here, and you can see it appearing on the bottom. I raise the clock and I drop it, and that bit shifts into the 2nd stage, and I can see that I've loaded a 1-1 at this point. Now if I drop this first input, raise the clock again, if I drop this first input and take another negative edge on the clock, we'll shift in a 0. So now we've got a 0-1-1 loaded in our shift register, and maybe I'll raise this to a 1 and I'll shift in a 1. So right now we have a 0-1-1, and on the next falling edge we get a 1-0-1-1. On the next edge we get a 1-1-0-1-1, and you can see our final bit value coming out of the 3rd cell from the top on this last stage of the shift register. So there's our 1, and if we just watch these bits, we should see 1-1-0-1-1 following each of the following edges. So there's our 1, we tick the clock and there's another 1, we tick the clock, there's our 0, we tick it, there's our 1, and we tick it again and there's our 1. And since our D input is still 1, we've got 5 stages of our shift register all filled with 1s. If I drop this to a 0 and I start ticking the clock, we begin shifting 0s in, and 5 steps later that 0 will start to appear on the output. So this is just a shift register. Again, it's not built the way that you would build this out of simple gates, but it functions as a shift register, and each of these is basically using that master-slave arrangement that we talked about in the edge-triggered D flip-flop lecture. An exercise to work on is to try to design a shift register using this or some other strategy, taking edge-triggered devices, putting them together in order to control a shift of an input through each stages following a transition of an input clock. So that's a homework problem. Have fun.